Hello, everyone. Welcome back. Today, we are going to be talking about financial applications. As you can see, there are 7 days in financial applications, plus the test review days. We're going to be talking about simple interest today. Then next time, compound interest. And then day 3 is also compound interest, but with other compounding periods other than annually. Day 4 is also compound interest, but calculating the number of payments. And day 5 is also compound interest found in the interest rate. On day 6 and 7, we'll talk about annuities, such as borrowing and investing. So let's start with simple interest. So first, I'm going to define simple interest and talk about what is the difference between simple interest versus compound interest. Now, the reason there are so many more days on compound interest is not only that it's more complex of a topic, but also because in practice, simple interest isn't really used ever, right? It's compound interest that's used. Simple interest is when we only owe interest on the principal, so the initial money we took out. So for example, let's say I borrow $1,000. I'm going to owe an interest rate only on that $1,000. Whereas with compound interest, let's say I borrow that same $1,000, I'm going to owe first, I'm going to owe interest on just that $1,000, but then I'm going to owe next time I'm going to owe interest on that $1,000 and the interest from the previous time. So the interest grows at a larger rate, at a faster rate when it comes to compound interest, because not only am I owing interest on my principal, but I'm owing interest on previous interest that I have not yet paid. So today we're going to talk about simple interest, even though it's not really often used in practice. It is still part of this curriculum, so we will still talk about it. Okay, so here is the formula for simple interest. Let me just grab. There we go. Okay, here is our formula for simple interest. It says I is the amount of interest, P is the principal, and R is the interest rate, and T is the time in years. So as you can see, the I, the amount of interest, is calculated by taking the principal, so the initial amount of money borrowed, times R, which is the interest rate, times T, the number of years. So this is simple interest per year. So for example, let's say the interest rate is 5%. And I borrow $1,000 and return it after 1 year, I'll need to return that $1,000 plus an extra $50 because that's the interest I now owe, given the 5% interest rate and given that it's been 1 year. Now, if it's been 2 years, I'm going to owe $100 in interest. If it's 3 years, I'm going to owe $150 in interest, and so on, right? Every year that I add, I'm going to now owe an extra $50, right? In this example. Okay. So again, interest, it is a fee charged by a bank or a person to another person for borrowing money, or a fee paid to a person by the bank for giving the bank money to hold onto, right? So interest can work for us or against us. If we owe interest, that's different from if we are getting interest from the bank or from investments or other stocks or whatever it is, right? So to calculate simple interest, again, we are going to use the formula I equals to PRT, where I is the interest earned, P is the principal, and R is the interest rate, and T is the time, always in years. Now, the principal can be money borrowed or money lent, depending on if we're the lender or the borrower, right? Maybe we let someone else borrow money, and they're going to owe us interest. The interest goes to us in compensation for letting them borrow that money. Or maybe we're the borrower, right? Maybe we are borrowing $1,000. In that case, we are the people owing the interest. So that's why it says here money borrowed or lent, because it just depends on your perspective, right? In any of these money situations, there's going to be a borrower and a lender. It just depends which person we are in that case, but it's the same deal, same way we calculate, regardless of if we're the borrower or if we're the lender. The tricky part about calculating the interest is the time must be in years for this to work. So for example, find T if you must invest a sum of money for 15 months. Now, the thing is 15 months, that isn't years. And what some people would be tempted to do is just put T equals 15, but that is incorrect. T does not equal to 15. T needs to be time in years. So if the time is given monthly, we need to divide the amount by 12 because there's 12 months in a year. And we end up realizing that T is going to be 1.25 years, right? 15 months is the same as 1 year and 3 months, which is the same as 1 1/4 of a year, or 1.25 years. And so that is the amount we're going to use for T. Another example here, they say 88 weeks. Now there's 52 weeks in a year, so we need to divide that by 52 in order to obtain that it's 1.69 years. So basically, if it's days, same sort of thing, except we would divide by 365. If it's decades, we'd multiply by 10, and so on. So anything we need to do in order to get, the time in years. Okay. Let's show an example actually using this formula. So it says here, Ray put $1,000 into a savings account. The interest on the account is 3.5%. He wants to put the money away for 3 years. How much will Ray have at the end of that time period? So before we look at the answer or look at how to do this, what's happening? Is he borrowing money or is he the lender? And in this case, he's a lender. He is putting money into a savings account. And the bank is saying that they will pay him 3.5% interest. So interest is good in this case for Ray. He is making money basically by leaving the $1,000 in the account and not touching it, not doing anything else with this money. So he wants to put it away for 3 years. So that means T is 3. The interest rate is 3.5%, and we're going to convert that to a decimal. So that's going to be 0.035. And P is the initial principal. So either money borrowed or money that is lent. In this case, it's money lent or put away into the bank. So $1,000 is how much he put in a savings account. So P would be $1,000. Then all we do is plug those numbers into the simple equation, and it's $105. So therefore, if Ray puts this $1,000 into the savings account and he leaves it there for 3 years, he will now have $105 in interest in addition to the $1,000 that he initially put in the savings account. So the amount of interest earned is $105. Now, if they wanted to know what was the total amount of money in the account, we would just add $1,000 plus 105 to get that it's $1,105 total in the account. So sometimes they'll ask, what is the interest? And sometimes they will ask, how much does the person have at the end of the time period? This time they asked, how much does he have at the end of the time period? So we're going to say $1,105. Okay. Here's another example. It says Beth owes $18,000 in student loan debt. The interest on her loans are 8.25%. She will be paying these loans off in 50 months. How much interest will Beth pay on her student loans? So basically 50 months, we have to convert that to years, remember? So we're going to convert that and say that 50 months is the same as 4.17 years. The interest rate is 8.25, which we're converting to decimal form, which is going to give us 0.0825. And P, the principal, the initial amount that Beth is borrowing, is $18,000. Okay, so that means that we're going to plug in these numbers and find out how much interest she will pay on her student loans. And it's quite a lot, mainly because that interest rate of 8.25%, that's a pretty high rate. And also, paying them off in over 4 years, it is a long time. So she's going to end up paying, in addition to the $18,000, an additional $6,192.45. In this case, they didn't ask the total she'll pay. They just asked how much interest she will pay. So therefore, this is the answer. It's $6,192.45 that she will pay in interest specifically, not paying off the principal, just interest. Okay. Let's move on to this one. It says, Dave owes Visa a lot of money for using his credit card. The interest rate on his Visa is 18.5%. He finally paid off all the money owed on his Visa after 300 days. How much did Dave charge to his Visa card if the interest charge was $183.63? So in this case, we want to know how much did he charge to his Visa. So we want to know what is the original principal that he borrowed. We know that the interest rate is 18.5%, which translates to 0.185 if we move it to decimal form. And we know that 300 days is the same as 0.82 years, right? We divide that by 365, we get how many years it took him to pay off the debt, which turned out to be less than 1 year. And then we know the interest is 189.63. That's how much he had to pay extra on top of the money that he had spent on his visa. So what we do is we use the same equation again, except it's P we're trying to isolate for. So we're going to figure out what P is, and we figure out that it's $1,250.03. So basically, the money he charged to his Visa card was $1,250.03, which makes sense. It's going to certainly be more than the interest that was charged, right? Okay, let's do one more because I believe, yeah, the next part is about compound interest, and that we're going to not tackle until next day. So this last example says Julia deposited $500 into her bank account. After 20 months, there was $516.17 in her account. At what interest rate was her money earning in the bank? So in this case, we want to know what is the interest rate. That's what we're interested in here. We know that P is $500. That's how much she initially deposits into the bank account. So that's her principal. She leaves it in there for 20 months, which is 1.67 years. And we know that the interest must be the total amount she has now minus the principal, right? We know that, we're trying to figure out how much extra money did she get from the bank. And the 500, she already put 500 in. So 500 of this money is not extra money. It's just the money she put in. It's just the $16.17. That's the extra money. That's the interest that the bank put in, as a reward for keeping the money in the bank. So that's what they did. $16.17 is the extra money she got on top of what she already deposited for her principal. So then what we do here is we use the same equation, but this time we're trying to find R. We want to find the interest rate, and we figure out that it's 1.9%. It was 0.019, which translates to 1.9%. So that was her interest rate, which is pretty typical for a lot of interest rates at the bank, even though that's not a very high interest rate, right? It's pretty low. That's fairly common for the bank. They're not going to give you as high an interest rate as they're going to charge for like a credit card or something. Okay, so that is simple interest. Now, do keep in mind, all of these examples are very much arbitrary. Simple interest is very rarely, if ever, actually used. It's compound interest, which is what we're going to learn over the next few days. That's important, but do keep the simple interest, equation in your head. Keep it to mind, because if you are ever asked for simple interest specifically, this is the equation you'll use. If you're asked for compound interest, there are other equations for compound interest that we'll go over the other days. But that is it for today, and we will see everybody for the next lesson. Bye, everyone.